Here we're going to look at testing two means using a GPA example. We have our formula for the two sample test statistic. That's our t-value. And then we have our formula for the confidence interval, which is the difference in two population means. And when we perform a hypothesis test or construct our confidence interval, we're going to use a smaller degrees of freedom. And you'll see what I mean by that in the example down here. So suppose a social scientist claims that the mean GPA of students who use a certain social media site is less than the GPA of students who do not use the social media site. Suppose the following sample data is collected. Okay, so the scientists came up with their hypotheses that the mean GPA for users of the site is less than the GPA for those who do not use the site. So they collected this data from two independent populations, those that use the site, those who do not use the site. And these are the statistics that they came up with. The first sample size was 128. The second sample size was 85. Okay, remember, those sample sizes do not need to be equal. So up here where I said use the smaller degrees of freedom, well, we have 128 and 85 for the sample sizes, so we're going to use 84 degrees of freedom. Okay, so in the first one, we want to construct a confidence interval for the difference in population mean GPAs of students who use the site and those who do not use the site. So here, it's not just a confidence interval for a population mean. So what do we expect the mean GPA of students who use the site to be? Okay, it's a confidence interval for the difference in population mean GPAs. So that means we're looking at a difference in means. So we're looking at a confidence interval for mu1 minus mu2. So this is the formula or expression that we're going to use. Okay, so you substitute in your sample means, find your t-star value for a 95% confidence interval, and then substitute your standard deviations and your sample sizes. Okay, and when you do that, this is what you end up with. I'm assuming at this point in this class, we can look up a 95% confidence interval using 84 degrees of freedom. That gives you 1.990 from your t-table. Okay, and then we substitute in our standard deviations and sample sizes. And then you end up with a margin of error of about 0.172. The difference in the sample means was negative 0.28. So your ending confidence interval is negative 0.452 to negative 0.108. So we're 95% confident that this interval contains the true value of the difference in means between the two groups. Okay, now, how do we interpret that? We look at this and we say, well, whoop-de-doo, we have a confidence interval, but what is it telling us? Interpreting the interval is the reason why we construct a confidence interval. So we can explain what it means. Well, when you look at the interpretation of the interval, we're always going to determine where 0 is located relative to the interval. So what we mean by that is, if the difference in means is greater than 0, then your entire interval would lie above 0. Okay, so if you subtract mu1 minus mu2, and you get a number greater than 0, so you get positive answers, so the difference in means is positive, it just means that you had a larger number minus a smaller number. So that would imply that the larger number, mu1, compared to the smaller number, mu2. Okay, so if your interval, your endpoints, both lie above 0, then that would imply that the first mean is greater than the second mean. Okay, now that's not what's happening here. In this one, we have a negative on the lower bound and a negative on the upper bound. So that's the case we have in the second bullet. if mu1 minus mu2 is less than 0. So if that happens, your entire interval lies below 0. This implies that the first mean is less than the second mean. To get a negative number, so less than 0 means you have a negative number. It means you had to subtract a smaller number minus a larger number. Okay, so that is what's happening here. We subtracted those that use the site compared to those that do not use the site, and we end up, we're 95% confident that our difference in means is going to be a negative number between these two. Okay, so that implies that the first mean is less than the second mean. Okay, so implying that the mean for the users is less than the mean for the non-users. Now the third thing that can happen, rather than your interval being entirely above 0 or entirely below 0, you could also have an interval that includes 0. So if 0 lies in your interval, that means that mu1 minus mu2 could have equaled 0. So that is plausible that the sample mean, that the population means were equal to each other. So that would imply that there is no difference in the population means. Okay, so those are the three things that can happen. And essentially what you're doing is you're comparing your difference in means to 0. So you look at the endpoints of your interval, and there's three things that can happen. Either that difference is larger than 0, or the difference is less than 0, or the difference contains 0, so it could equal 0. Okay, so those are the three things that can happen. Okay, so what does our interval suggest about the mean GPA of students relative to whether they use the site? Well, we already answered that. We have negatives on both bounds. So our entire interval lies below 0. Therefore, it appears that the mean GPA for the users is less than the mean GPA for the non-users. Okay, so it appears that the mean of the users minus the mean of the non-users is less than 0. Okay, on the second side, there's another question. Now we're going to test the claim with alpha equals 0.05 that the mean GPA of students who use the site is less than the mean GPA of students who do not use the site. So this is kind of the same thing we just did with the confidence interval, except that was just using a confidence interval. Well, now we're going to actually perform an actual hypothesis test. Okay, so you set up your hypotheses. So they're looking at the mean GPA of the users is less than the mean GPA of the non-users. So you set up your hypotheses. That says user here. The mean of the users equals the mean of the non-users. And you can use subscripts of 1 and 2 if you wish. You should just write group 1 equals users, group 2 equals non-users off to the side. Much of the time I like to write the little subscripts there so we know exactly what we're saying. And then the claim, which happens to be the alternative in this case, is that the mean of the users is less than the mean of the non-users. Okay, so once you write your hypotheses, you set up your rejection region for HO. So if we have 0.05 for alpha, we have a critical number t of negative 1.664. And that's using the degrees of freedom of 84 again. Okay, so 84 degrees of freedom. So we have 5% and 1 tail, or 0.05 and 1 tail, with 84 degrees of freedom. So you have to go up to the 80 degrees of freedom in your table. Okay, and I'll point out again that you can write your hypotheses this way. The mean of the users minus the mean of the non-users could equal 0 compared to being less than 0. So the difference could be 0 or less than 0. Okay, and that was just by subtracting the mean of the non-users to each side. And you can write your hypotheses this way. Okay, so we calculate our test statistic using that equation on the first side for your t-test statistic. When you do this, I suggest you do the entire denominator at once. Do the numerator first. and then the denominator, and then divide them. And when you do that, you end up with a t-value of negative 3.242, which is over here on the left side of the critical number t. Okay, so your test statistic is way out here on the left. So if the means really were equal to each other, then getting this getting the sample of difference of 2.97 minus 3.25, so a difference of negative 0.28. So getting that difference would be unusual if the population means were really equal to each other. Okay, so that means we reject the null hypothesis, which means we can support the alternative, which means we can support the claim that the mean of the users is less than the mean for the non-users. Now the last example, we're testing a claim with alpha equals 0.05 that the mean GPA of students who use the site is less than 3.10. Now when you read this one, are they asking you to test a claim that one GPA is less than another GPA? No. They're looking at the group of the users compared to a number. So this goes back to previous content where you were just looking at comparing the mean of the users being less than 3.1. Okay, so in your hypotheses here, now you're back to the old ones. The mean equals 3.1 is your null. The mean less than 3.1 is the alternative. Now we have 127 degrees of freedom because now we're only looking at the users. With alpha equals 0.05, that gives us a critical number, t equals negative 1.660. So now we're back to the easier formula for finding your test statistic, your one sample test statistic for t. And then you end up with negative 1.772, which is just to the left of this critical number. Okay, so your test statistic is still in the rejection region. So we're going to reject HO. There's enough evidence to support the claim that the mean GPA is less than 3.1 for all students who use the site. Now the reason I asked you this one was just when you go through questions, you need to recognize what kind of hypothesis test it is and what formula you're going to use. Okay, on this last one, we're only back to the one group again. Compared to this one up here, we were looking at the mean of two groups. Okay, so it's up to you to recognize which hypothesis test or confidence interval we're actually working with.